Hello, el- uh, eighth grade math students. We are learning online today because it's cold and apparently snowy. Here we go. Now, um, we're going to kind of skip ahead a little bit. What we were going to do, remember, is we were going to solve systems of linear equations graphically, and we will get back with that. But I can't guarantee that everybody has graph paper at home. So rather than try to do that lesson or go back and review something that we did before, we're going to forge ahead and do this algebraically. We were headed in this direction anyway. We'll just get there a little bit earlier. Here's what you got to do. Um, you want to click the link on my planner so that you can get to this worksheet. You don't need to print it out. If you want to, you can if you have the ability. If you don't have the ability or don't want to, you don't need to print this out. This just contains the problems that we're going to work as well as the answers. So as you do these, if you don't see your answer in the answer boxes, perhaps you didn't do the problem correctly. This can be a little confusing, so please pay attention. If you need to rewatch the video multiple times, it's okay. Um, you have the video available for you. But this is called solving a system through substitution. And on a piece of paper, yes, you are going to need a piece of paper, write down the problem. Problem number one here says y is equal to 2x, and also that x plus y equals 12. Solving a system means that we're going to look at in this case, two different equations with two variables, and we're going to try and figure out what points they have in common. To do that, we're using what's called substitution. Substitution rhymes with constitution, but is completely different. For substitution, what we're going to do is look at this first equation. It says that y is equal to 2x. Okay? If y is equal to 2x, then I can substitute or exchange 2x where I see y in the other equation. All right? Since they're equal to each other, it doesn't matter if it says y here or if I replace it with 2x. The end result will be the same. In other words, I can say x, that came from here, x plus, now I'm not going to write y, instead I'm substituting in 2x. And I have my equal sign, and I still have 12. So I've rewritten this second equation. There it is. The only difference is I substituted 2x for my y. And the reason I could do that is because it told me in the first equation that y was equal to 2x. If they're equal, then I can just trade places. Okay? They can just trade places there. So now we can work this problem like we've worked other problems. On this side of the equation, I see the same thing. What do we do when we see the same thing on the same side? Yes, that's right. We simplify or we combine our like terms. 1x plus 2x's is 3x's, and that's still equal to 12. How do I get x by itself? Let's divide both sides by 3. And so we'll get x is equal to 4, since 12 divided by 3 is 4. Okay? Now that gave me an x, but it didn't give me the y yet. So there's a second part to this, and here's how that works. Since x is 4, I'm going to go back up to this equation where it said y equals 2x, y equals 2. But I'm now going to substitute this in for my x. Y is equal to 2 times 4. Since my x is 4, 2 times 4. See where that came from? Y equals 2 times x is the same as y equals 2 times 4 as long as x is 4, right? So we'll do that math and we get y is equal to 8 since 2 times 4 is 8. Now the way that we write our answers down is these are ordered pairs. Remember, ordered pairs are in XY form, right? So inside parentheses, we're going to write the x and the y separated by a comma. Our x was 4, our y was 8. So the answer to this is the point 48. Big picture time here, okay? We are trying to find, when we have two linear equations, or two lines if we graph them, what points they have in common. And so we use the substitution method to find the xy value, or the point that these two lines have in common. Okay, we've solved the system. All right, I'm going to do the next one with you as well. Follow along. And again, if you get lost, you can always pause and rewind the video. But here's like problem number 2. It says, go right down to, it says x equals 3y minus 1. And the second equation is x plus 2y equals 9. In this first equation, you see how x is all by itself? Kind of like when we looked at the first equation in this problem, y was all by itself, but it said equal to something. And then we were able to replace the y in the other equation with that thing. Here, x is by itself, but it's equal to this thing. So we could replace the x in the second equation with that thing. So in other words, we're going to take this and put it in where we see x in the second equation. So I'm rewriting this equation, but instead of writing x, I'm going to write 3y minus 1, since I'm replacing the x in the second equation with what x was equal to in the first equation. That's called substitution. I'm substituting in what x is equal to into the second equation for my x, right? So 3y minus 1, that's now replacing my x, but I still have plus 2y, and it's still equal to 9. I've rewritten this equation right here, and the only difference is that this 3y minus 1 was substituted in for x, since x was equal to 3y minus 1. So I've just taken this and I've plugged it in where the x was, okay? Now, we can solve such things. Again, looking at this equation, since I have the same thing on the same side, we can combine our like terms. 3y plus 2y is 5y, and I'm subtracting 1, and that's equal to 9. Okay, I just combine my y's. Since I want to get my variable by itself, look for any addition or subtractions happening. Oh, here's some. How do we get rid of a negative 1? Well, we can add 1 to both sides. 5y equals 10. We still don't have y quite by itself, but we're close. We just need to divide both sides by 5. And that will give us y is equal to 2. Okay? Again, I'm not quite done. Remember, in the first problem, we found out what one of the variables was, and then what did we do? Well, we substituted in the other equation what we found the value to be. We're going to do the same thing down here. Since y is 2, I'm going to come back up here and say, well, x is equal to 3 times 2 minus 1. Where'd the 2 come from? That's what y is. Y was 2, so I replaced my y with 2, or I substituted in my 2 for my y. Now we'll just do the math. X is equal to 3 times 2 is 6 minus 1, so x is equal to 5. Okay? How do we report our answers? Our answers are always this ordered pair. So we're going to put our x and y that we found inside parentheses separated by a comma. It's a point, it's a coordinate where the lines cross. In this case, our x was 5 and our y was 2. So the point they have in common is the point 5, 2. Okay? That's how we do these problems. Now, all's well and dandy till you come up with something like, oh, I don't know, number 7 over here. Number 7 says that negative 2x plus 3y is equal to 14. And then it says x plus 2y is equal to 7. Okay? The difference between this and something that we looked at before is that when we looked at problem number 1, y was already by itself. When we looked at problem 2, x was already by itself. They'd already gotten the variables by themselves, okay? And since the variable was by itself and we knew what it was equal to, I could then substitute it into the other equation. But for number 7 and on down on this worksheet, we don't have a variable by itself. But we're supposed to be good enough at algebra that we can get a variable by itself. Take a look at the second equation. How could I get a variable by itself? Well, it would be very simple to get x by itself. All I would have to do is subtract 2y from both sides. Okay, if I do that, I'm going to get x is equal to a negative 2y plus 7. Stop and look at it if you need to, but that's what you're going to get. So that allows us to be in a similar situation to what we were over here on problem number 2. X is by itself. This was equal to 3y minus 1. We have gotten x by itself. Now it's equal to negative 2y plus 7. So what we're going to do, because this is the substitution method, is we're going to take this 2y plus 7 and we're going to put it into the other equation where there was an x, okay? So what we do is we take one of our equations, this one right here, for example, and we solve for a variable. Once we get the variable by itself, we put what it's equal to into the second equation, let's call it 2, and replace that variable there. So in other words, I'll just scoot this over so we can see what's going on. I'm going to rewrite this equation up here. It's negative 2, but instead of writing x, I'm going to write minus 2y plus 7, since that was what x is equal to. So what I've done is I've taken negative 2, and instead of writing x, I wrote negative 2y plus 7. Okay, that's my substitution. But I still have a plus 3y that I need to add on here, plus 3y. I still have an equal sign, and I still have a 14. So now I've rewritten this equation, but substituted in the x that I found before. Okay, now that we've got that in there, let's distribute. Negative 2 times negative 2y is 4y. Negative 2 times 7 is minus 14. We still have plus 3y, and it's still equal to 14. Since I have the same thing on the same side of the equation, I can simplify. So we're going to take 4y plus 3y to make 7y. Still minus 14, still equal to 14. I'm trying to get the y term by itself, so we look for any addition or subtraction that's happening. Here, I see some subtraction. How do I get rid of a negative 14? I can add 14. What you do to one side, you do to the other side. That gives us 7y is equal to 28. Still looking to get y by itself. We're going to divide both sides by 7. And these 7s cancel and leave me with a y. 28 divided by 7 is 4. So I know that y is equal to 4. We're not done. How do we finish the problem? Well, we're going to now substitute in our 4 for the y over here. In other words, I can write x is equal to negative 2, but I'm not going to write a y. I'm going to replace that or substitute in 4. Negative 2 times 4 plus 7. Okay? Let's do the math. Negative 2 times 4 is negative 8 plus 7. What do you get when you take negative 8 plus 7? Well, you get negative 1. So my x is negative 1, my y is 4. We report the answer as an ordered pair. Our x was negative 1, our y was 4. This is our solution to the system. This is the common point that these two lines have in common, okay? I told you before, this is complicated, right? The first time you see it, first couple times you see it, it's a process, okay? But you can do it. Take your time, work through it. If you need to go back and rewatch this video, please rewatch this video. Again, this is a worksheet that has a puzzle, right? That just keeps it kind of interesting and maybe a little more fun to do. But as I've said before, we're doing the math here, okay? The answer to the puzzle is not as important as how to do the problem. So please make sure that you are writing your problems on the paper and you're going to have to show your work. You don't do these in your head, okay? This is not something you do in your head and say, I just did it in my head. No, you didn't. Anyways, good luck, stay warm, and hopefully we'll see you on Friday, okay? Bye-bye.